Dear friends, today we will consider solution of linear differential equation with constant coefficients. And already in the previous video we discussed about what is a homogeneous differential equation, what is non-homogeneous differential equation, and what is a linear differential equation of order n. Now we will consider a second order linear differential equation which is homogeneous of order 2. That is, suppose we have a differential equation of order 2 as a naught to d square y by dx square plus a1 into dy by dx plus a2 of y is equal to a2 into y is equal to 0. Let us call this is equation as 1, where here a0, a1, a2 are all constants. Now let us write this in a simplified manner by taking d by dx is equal to capital letter D and d square by dx square is equal to d square. Then that equation becomes d square y plus a1 into dy plus a2 of y. Then taking y common, the equation can be written as d square plus a1d plus a2 of y is equal to 0. Then let us put LD is equal to d square plus a1d plus a2, so that the given equation, that is this equation can be written as LD of y is equal to 0, where L is the linear differential operator. Now let us construct the auxiliary equation, that is AE, as L of m is equal to 0. That is just we replace d by m in LD. So now you may ask why we should take L of m is equal to 0. See, here we already know that A into B, two numbers A into B is equal to 0 means either A is equal to 0 or B is equal to 0 or both is equal to 0. Here LD is taken as A, Y is taken as B. Since this Y is a dependent variable, it cannot be 0. So LD is equal to 0 we can take. That is L of D is equal to 0 we'll get. Now by putting D is equal to m in this becomes the auxiliary equation. Auxiliary equation means we can write that one as m square plus a1m plus a1m plus a2 is equal to 0, which is a quadratic equation. It is a quadratic equation. Now since it is a quadratic equation, it can be solved by using either factorization method or Sridhara's rule. If factorization is not possible, then on solving this, definitely you will get two roots, say m1 and m2. Now to write the solution of equation 1, that depends on the nature of these two roots. Now depending on the nature of the roots means the solution of the equation 1 can be written as this. Three types of the roots can exist here. That is case number 1, roots may be real and distinct. That is, let m1 and m2 be real and distinct. That is m1 and m2 are real, but those two are not equal. Then the general solution of equation 1 is written as y is equal to c1 into e to the power m1x plus c2 into e to the power m2x. And if it is a third and higher order, third, fourth or fifth order, so on, then if all the roots are real and distinct, then this method can be extended to third, fourth and higher order. Now let us take quickly on the case number 2. Roots are real and equal. That is, let m1 and m2 be real roots and equal roots. That is, m1 and m2 are real, and those two roots are equal. Let us say some number m. Then the general solution of the equation 1, that is equation 1 is given equation, homogeneous equation, that can be written as c1 plus c2x into e to the power mx, or y is equal to c1x plus c2 into e to the power mx. We can write if it is third order differential equation, then this can be extended to third order, fourth order, fifth order also. That we will discuss when we solve the problems of third order, fourth order and so on. Then case number 3, another the type of the roots, that is a complex roots. That is, the given roots m1 and m2, it is not necessary that roots must be real and equal and real and distinct, but roots sometimes it may be, if the factorization is not possible, sometimes the roots may be complex roots. So whenever we talk about the complex roots, keep in one mind keep one word in mind. Complex roots always exist in pairs. That is, if one root is alpha plus I beta, another root must be alpha minus I beta. Complex roots always exist in pairs. That is, let m1 is equal to alpha plus I beta and m2 is equal to alpha minus I beta be the roots of the given equation. Then the general solution of equation given homogeneous equation that can be written as y is equal to e to the power alpha x into bracket a plus a cos beta x plus b sin beta x, where this a and b are the constants. Now this can be obtained by using case number 1, that is because m1 and m2, these two are complex numbers conjugate of each other. Here real part is equal but imaginary part is same but with the opposite sign. So these two numbers are set, these two complex numbers are not equal because of the imaginary parts. Now this is about how to write the solution of the homogeneous differential equation depending on the nature of the roots. Now we'll take some examples of second order first to understand these how to write the solution. Then we will go to the higher order differential equations. Now note that these above cases are applicable to third or higher order differential equations also. Now let us consider examples one by one. Number 1, solve the differential equation d square y by dx square plus dy by dx minus 2y is equal to 0, or sometimes this equation can be written as y double dash plus y dash minus 2y is equal to 0. Now by substituting d is equal to d by dx, that is d is equal to d by dx and d square is equal to d square by dx square, the given equation can be written as d square plus 2d minus 2 of y is equal to 0. Once we write this becomes a L of d. Therefore the auxiliary equation can be written as L of m is equal to 0. That is, wherever d is here, you need to substitute m. That becomes a m square plus m minus 2 is equal to 0. That is, now this is a quadratic equation. Now let us check whether, concentrate on this number, whether is it possible to divide this number or factorize this number into two numbers such that if you add you must get plus 1, if you multiply you must get minus 2. You need to choose two numbers. Therefore here it is possible. That is, if we take plus 2 and minus 1, plus 2 into minus 1 is minus 2, and plus 2 minus 1 is plus 1. Therefore this equation can be written as m square plus 2m minus m minus 2. Okay, therefore now let us consider first two terms here. From the first two terms we can take m common and we can write this one as, after taking m common from the first term you left with the m, and from this term you left with the 2 plus 2. That is, now these two terms are with the negative sign, so that we need to take care that here you must get a m plus 2 so that we can take that factor common. So these two are with the negative sign, means we want m plus 2 here, so we'll take minus common from this, so we can write this one as, that is, in other words, minus 1 should be taken common. It can be written as a m plus 2 is equal to 0. Now let us write this one as, taking m plus 2 common from these two terms, we can write m plus 2. From this term m is left, from this term minus 1 is left, so we can write into m minus 1 is equal to 0. Now equating separately these two factors to 0, that is m plus 2 is equal to 0, m minus 1 is equal to 0, you will get here from this factor, taking this 2 to this side, m is equal to minus 2, and taking this factor to this side, you will get m is equal to plus 1. Therefore m is equal to minus 2 and plus 1 are the roots. Now check the nature of the roots. This is minus 2, this is 1. Those two are real numbers, but those two numbers are not equal. So we can say case number 1, roots are real and distinct. Therefore here m1 is minus 2, m2 is 1. Therefore the general solution is written as y is equal to c1 into e to the power minus 2x plus c2 into e to the power x, or you can also write this one as c1 into e to the power x plus c2 into e to the power minus 2x. No issues with that. So This is solution of the general solution of the given differential equation. Now to understand it much better, or to understand to do, we'll take a different example. Now example number 2, that is solve the differential equation, or simply solve d square y by dt square minus 18 times dx by dt plus 81 x is equal to 0. Now here it clearly indicates that here it is dy by dx in the first example. Here it clearly indicates that x is the dependent variable and t is the independent variable. That means we have to solve it for x in terms of t. Solve it for x in terms of t. Therefore, now the given equation can be written as dx double dash minus 18 times x dash plus 81 of x is equal to 81 into x is equal to 0, where here x dash is dx by dt and x double dash is d square x by dt square. Further, this equation can be written as d square minus 18d plus 81 of x is equal to 0, where we have instead of d by dx, since x is a dependent variable, t is independent variable, we write calculator d is equal to d by dt and calculator d square is equal to d square by dt square. Substituting this and taking x common, this equation can be written as a d square minus 18d plus 81 of x is equal to 0. Now this is your LD. This is our L of D. Now, therefore, the auxiliary equation, the rules to write the auxiliary equation is wherever D is there, we need to substitute that by M. Okay, therefore, replace that by M. So, therefore, the auxiliary equation can be written as L of M is equal to 0. L of M is equal to 0. So, this becomes M square minus 18M plus 81 is equal to 0. Plus 81 is equal to 0, which is the auxiliary equation. Now this is a quadratic equation. We need to solve this. Now you can observe this equation. This is of the form a square minus 2ab plus b square plus b square. Okay, that can be written as a minus b whole square. That is, here you can think about you can take a M as a and a 9, that is this becomes 2 into 9 into 2 into m. Then this is 9 square. So you can write this one as directly m minus 9 whole square, which can be written as m minus 9 into m minus 9 is equal to 0. That is, m minus 9 is equal to 0 means m is equal to 9, one of the root, and another root is also m is equal. If you are not familiar with this, so we can go for a factorization method. That is, the last number is plus 81 here. You have to split this in such a way that if you add, you must get a minus 18. If you multiply, you must get plus 81. That is, minus 9 and minus 9 are the two numbers. So on factorization, on rewriting this, you will get m square. This is m square minus 9m plus 81 is equal to 0. Therefore, from the first two terms, if we take common m, this becomes m minus 9, and from the second two terms, third term and fourth term, you take minus 9 common, this becomes m minus 9. Again, from these two factors, you can take m minus 9 as a common factor, m minus 9 here, m minus 9 into m minus 9 is equal to, which is same as this. Okay, so m is equal to 9, m is equal to 9 are the roots. Okay, that is, m1 is also 9, m2 is also 9. So both the roots are real and both the roots are equal here. Therefore, by observing this, we can decide that the roots are real and equal. Now, to write the general solution of this equation, we will use the second type, that is, x is equal to c1 plus c2 x is equal to c1 plus c2t into e to the power 90, or you can also write this one as x is equal to c1t plus c2 into e to the power 90. Okay, this is called the general solution of the given differential equation. Now we have taken one example on real and equal roots and real and distinct roots. Now let us take one second order example to understand how to write the solution when the roots are complex in nature. So let us take one more example here, that is, solve the differential equation y double dash minus 6y dash plus 13y is equal to 0, or this example can be written as already d square y by dx square plus minus 6 dy by dx plus 13y is equal to 0. Now again substituting a capital letter d is equal to d by dx, and d square is equal to d square by d square by dx square, and on simplification we will get that is given equation can be written d square minus 6d plus 13 of y is equal to 0. Then this is your L of d. Now as usual we need to construct the auxiliary equation first and foremost is it is therefore the auxiliary equation is L of m is equal to 0. That is L of m is equal to 0. That is now we will get if you write L of m is equal to 0, that means m square minus 6m plus 13 is equal to 0. Now first and foremost thing, since it is a quadratic equation, first and foremost thing we need to concentrate on this constant number 13, whether factorization is possible or not. See, factorization is not possible here. That is, if you multiply you must get 13, if you add you must get minus 6. So it is not possible to find two numbers such that if you multiply you must get plus 13 and if you add you must get minus 6. So we go for one of the famous method which is called as Sridhara's rules, that is x is equal to minus b plus or minus b square minus 4ac divided by 2a divided by 2. That is here in this case a is coefficient of this one, that is a m square, that is a is 1 here, b is coefficient of m, that is a minus 6, and c is constant term, that is 13. So if we substitute all those values in this equation we will get m is equal to 6 plus or minus under square root 36 minus 4 into 1 into 13, which will after simplification which will become 6 plus or minus 36 minus 13 fours are 13 into 1 is 13 only, 13 fours are 52. So you will get 36 minus under square root 36 minus 52 divided by 2, that is 6 on simplification 6 plus or minus 36 minus 52 means that is minus 16 divided by 2 minus 16 under square root 16 is 4, but under square root minus 1 is that is I, which is a imaginary number, so we can write that one as m is equal to 6 plus or minus 4i divided by 2, that is 3 plus or minus 2i. Therefore here two roots are there, two values of m. One is 3 plus 2i, another one is, that is let us say this one as m1, and another one is m2 is equal to 3 minus 2i. Let us say this is m2. So now these two roots are complex in nature and one is conjugate of other. You can observe here the roots are complex in nature, that is alpha plus or minus I beta is equal to get 3 plus or minus 2i. Now using case number 3 you can write the general solution of given equation as y is equal to e to the power 3x into bracket a into cos 2x plus b into sin 2x. And one more thing, here it is not necessary that you have to take a and b only, you can take a c1 and c2 also, okay. Now this is about how to solve the second order homogeneous differential equations. Now we will move a little bit ahead and we will take a third, fourth and fifth or higher order differential equations. Now we will take one more example on second order linear differential equation, that is homogeneous linear differential equation. Then we will move to the third order and fourth order differential equations. Now for example, you can solve the differential equation d square minus 3d plus 2 of y is equal to 0, or this can be asked as d square y by dx square plus 3 times dy by dx plus 2y is equal to 0. Now to solve this equation, as usual, we need to substitute d by dx is equal to capital letter D, d square y by dx square is equal to capital letter D square, and after substitution of those we will get that this equation can be in simplified format. It can be written as d square minus 2d plus 2 of y is equal to 0. Therefore now this is your L of d. Okay, now in this, to write the auxiliary equation, wherever d is there you need to substitute m and make it equal to 0, that is L of m is equal to 0. Now once it is L of m is equal to 0, since it is second order differential equation, then it becomes m square minus 3m plus 2 is equal to 0. Now Since this is a quadratic equation, we need to think of first factorization. That is, we need to concentrate on this number, that is 2, and we need to concentrate on this number, that is minus 3. We have to find two numbers such that if you multiply, you must get plus 2. If you add, you must get minus 3. So two numbers are minus 2 and minus 1. If you multiply, minus 2 into minus 1 is plus 2, minus 2 plus, that is minus 1, is equal to minus 3. So these two are the required numbers. So this can be written as m square minus 2m minus m plus 2 is equal to 0. Now we'll concentrate on first two terms of this equation. That is, first two terms are m square minus 2m. From these two terms we can take m common and we can write this one as m minus 2. And next we need to concentrate on last two, that is third and fourth terms. That is, one is minus m and plus 2. So we want from these two terms we need to rewrite this one as m minus 2. So for that purpose we have to take a minus common from this. So we'll write this one as a minus 1, which becomes m minus 2, so that after simplification the original thing will remain as it is. So from this entire quantity, from this entire equation, we can take m minus 2 common, and we left with from the first terms we left with the m, and from the second term we left with the minus 1. So this becomes m minus 2 into m minus 1 is equal to 0. So m minus 2 is equal to 0 and m minus 1 is equal to 0 leads to m is equal to 2 and m is equal to 1. Therefore m is equal to 1 and 2 are the required roots, and these roots, by the nature, these roots are real and distinct. Therefore, using case 1, the general solution of equation, given homogeneous equation, can be written as y is equal to c1 into e to the power x plus c2 into e to the power x, which is the required required solution. Okay, now this is about we taken 4 examples on how to solve the second order differential equations, homogeneous differential equations. Now we'll move on to the third order homogeneous differential equations. One by one some examples we'll consider. So that is, solve the differential equation, or simply solve d cube y by dx cube minus 3 times dy by dx plus 2y is equal to 0, or the same thing can be given, same equation can be given as a d cube minus 3d plus 2 of y is equal to 0. Okay, if it is given in this manner, no issues, directly you can write the auxiliary equation. If it is given in this manner, first we need to rewrite this in this form, then we have to consider the auxiliary equation. Let us write this equation, that is d cube minus 3d plus 2 of y is equal to 0. Now this is your L of d here. So to construct the auxiliary equation, we need to substitute wherever d is there, we need to substitute m. So make it to equal to 0. That is, the auxiliary equation becomes L of m is equal to 0. So the auxiliary equation is m cube minus 3m plus 2 is equal to 0. Now since this is a third order equation, linear differential equation, we will get 3 roots here, but here you observe m square term, that is m square term is missing. So directly using either Sridhara's rule or by factorization method is not possible to find the root. First we need to extract one of the root by using two methods. One is called either of the two methods. One is called by inspection method and another one is called synthetic division method. Okay, now instead of going for division method, we will go for synthetic division method. So in the synthetic division method, what we need to write down the coefficient of all these terms. Even the missing term coefficient should be written as 0. That is, highest term coefficient, m cube coefficient, is 1. M square is not there, so this coefficient should be written as 0. M coefficient is minus 3 and constant term is 2. Now below the highest term coefficient, you write it as a 0, and now we start finding root by trial and error method. That is, first we will try to divide it by that is 1. So 1, so you have to keep this 1 as it is, then multiply this 1 and 1, then write it here and add this to this, that becomes 0 plus 1 is 1, then again multiply this and this, then this becomes 1 into 1, this is plus 1, again it is a 1 here. So minus 3 plus minus 3 plus 1, it is minus 2. So 1 into minus 2 is 2, 2 minus 2 is 0. If the last term it gives a remainder as 0, then we say that this 1 is one of the root of this equation. Therefore here it gives the 0 here, remainder. So m is equal to 1 is a 0 and therefore m minus 1 is a factor of this equation. Now we have extracted one root. Once we have extracted one root, this equation can be reduced to the that is, it will be reduced to second order or quadratic equation. That is, this equation can be written as m minus 1 into, using coefficients of these, we can write the second equation. That is, highest coefficient of highest term is after extracting one root, this is this one, then least, then this is the constant term. So this becomes m square plus m 1m, that is minus 2, is equal to 0. So m minus 1 into m square plus m minus 2 are the two factors of this equation. Now make these two factors equal to 0. M minus 1 is equal to 0. M square plus m minus 2 is equal to 0. Now already from this we know that m is equal to 1 is the root. Now we need to solve this. To solve this, again this is a quadratic equation. Now we need to concentrate on this number, that is a 2. If you multiply, you must get minus 2. If you add, you must get plus 1. So you have to find such two numbers. Such two numbers, you can find them as plus 2, then this is minus 1. So that if you add them, you will get a plus 1. If you multiply them, you will get minus 2. So it can be written as m square plus 2m, or you can write minus m also first here, no issues. Then minus m minus 2 is equal to 0. So from the first two terms, we will take m common. It can be written as m plus 2, and from the last two terms, that is these two terms, you can take minus 1 common and you can write as m plus 2. So m plus 2, m minus 1. So taking m plus 2 common, m plus 2 and m minus 1 are the factors, making these two factors equal to 0. That is m plus 2 is equal to 0. This gives you m is equal to minus 2 as one of the root. Then m minus 1 is equal to 0. This gives you m is equal to 1 as one of the root. Therefore already you have one of the root here, that is m is equal to, therefore m is equal to 1, 1 and minus 2 are the roots. Here you can observe two roots are real. See, of course all the three roots are real, but two roots are equal, one root is distinct. Therefore here when you write the general solution, we need to consider case number 1 and case number 2 both. So first, considering case number 2, you can consider 1 and 1 as the root. So you can write with respect to these two roots, you can write the general solution as c1 plus c2x into e to the power x, and with respect to the third root, you can write this one as plus c3 into e to the power minus 2x. So you can observe one thing here. These c1, c2, c3 are the constant. These constants will be equal to the number of roots. That is, how many number of roots exist, those number of constants should exist, and number of roots will be equal to the order of the differential equation. So this is the required solution for the given third order differential equation. Okay, now to understand it much better, or we'll take some more examples here. That is one more example is solve the differential equation. D cube y by dx cube plus 1 plus y equal to 0. So this equation, after substitution, d is equal to d by dx, and d square is equal to d square y by dx square. Similarly, d cube is equal to, capital letter d cube is equal to d cube by dx cube. This equation can be written as in the simple form as d cube plus 1 of y is equal to 0, where this is your L of d. Therefore the auxiliary equation becomes L of m is equal to 0. The auxiliary equation L of m is equal to 0 means m cube plus 1 is equal to 0. Now here this is a cubic equation. Here two terms, m square is also not present, m is also not present. Here we can use either synthetic division method, or we can also use a inspection method. Instead of that, here in this case, using synthetic division method and using inspection method becomes a little bit difficult for you. So we can remember one of the basic formulas of algebra, that is a cube plus b cube is equal to a plus b, then into a plus b into a square minus ab plus b square. Here comparing this with this, a is equal to m and b is equal to, you are having 1. So using this formula in this equation, you will get m plus 1 into m square minus m plus 1 minus 1 plus 1, this is equal to 0. Therefore this is your A, this is your B now. So A is equal to 0, B, that means we need to equate this factor and this factor separately to 0 to get the required roots. So m plus 1 is equal to 0 leads to m is equal to minus 1 as one of the root. Now consider this one, m square minus m plus 1, m square minus 1 plus 1 is equal to 0. This is a quadratic equation. Once it is a quadratic equation, we need to concentrate on this number 1 and this coefficient of m minus 1. So we have to get two numbers such that if you multiply you must get plus 1, if you add you must get minus 1. Here factorization is not possible. Factorization is not possible. Okay, factorization is not possible. So what we will do there, factorization is not possible means for Sridhara's for the quadratic equation we go for Sridhara's rule, which is, once again I'll write it, which is if your equation is ax square plus bx plus c is equal to 0, so quadratic equation, solution of this quadratic equation is given by Sridhara's minus b plus or minus b square minus 4ac divided by it is 2a. Here comparing this equation with this, you will get a is equal to 1, b is equal to minus 1 and c is equal to 1. Therefore substituting these values in this equation, in place of x we have m here, therefore m is equal to, you will get 1, that is minus into minus plus 1 plus or minus 1 minus 4 into 1 into 1, because a value is also 1, c value is also 1, divided by 2 into 1. Okay, therefore m is equal to 1 plus or minus, further simplification leads to 1, 4 into 1 into 1 is 4 only, 1 minus 4 is under square root minus 3. We will get under square root minus 3 means root 3, it is not a perfect square, so you can write it as root 3 only into I, because root 1 value is I. Therefore m is equal to minus 1 and 1 by 2 plus or minus root 3 by 2 are the required roots. Now here you can observe two roots are complex in nature and both the roots exist in pairs. That is, one root is 1 by 2 plus root 3 by 2i, another root is 1 by 2 minus root 3 by 2i. Therefore three roots already you got there. Therefore with respect to this, using case number 1 and case number 3 you can write the solutions. Therefore the general solution is y is equal to c1 into e to the power minus x plus c2 into, here alpha is 1 by 2 and beta is root 3 by 2i. Therefore you can write this one as e to the power 1 by 2 times x into bracket c2 into cos root 3 by 2 times x plus c3 into sine root 3 by 2 times x, which gives you the required solution of the given differential equation. Okay, no, okay, we will move on. Then I will take one more equation of order 4. Okay, that is, solve the differential equation. D raised to 4, fourth order derivative of y with respect to x minus a raised to 4 into y is equal to 0, or this can be written as d raised to 4 minus a raised to 4 of y is equal to 0. So it is understood that capital letter D means d raised to 4 divided by dx raised to 4. Therefore now if it is given in this format, directly you can write the auxiliary equation. If it is given in this format, then first you need to rewrite this in a simplified format like this, then you have to write the auxiliary equation. Therefore the auxiliary equation is written as L of m is equal to 0, which is nothing but m raised to 4 minus a raised to 4 is equal to 0. Now this is a fourth order differential equation. Fourth order differential equation means you must get 4 roots here. You must get 4 roots. So how to get those 4 roots? Here factorization or inspection method, synthetic division method becomes a little bit more complicated. So what we need to do, think on this. That is, here we have one of the important result, of the basic important result, that is, we already know a square plus b square is equal to a plus b into a minus b, a plus b into a minus b. So this equation can be written as m square whole square minus a square whole square. See here, a is nothing but m square, b is nothing but a square. So using this a plus b into a minus b formula, you can write this equation as m square plus a square into m square minus a square. Now these are the two factors. Now make these two factors equal to 0. That is, m square plus a square is equal to 0, m square minus a square is equal to 0. On solving these, First we will solve this. On solving this equation, m square is equal to, let us take this is a constant, let us take this number to this side, that is m square is equal to minus a square. So finding the value of removing the square root, you will get squares, you will get m is equal to plus or minus ai, that is actually you will get here m is equal to plus or minus under square root minus a square minus a square minus a, sorry, a square means you can write it as a, then under square root minus 1 means you can write it as a I, therefore it becomes a plus or minus ai. Now coming on to this, therefore here it is m square minus a square is equal to 0. You can solve it in a two ways, that is, one is directly transfer this a square to this side, this becomes m square is equal to plus a square. M square is equal to plus a square means m is equal to, you will get plus or minus a r. If this is possible, you can do this way, or if you are getting confused, again you go back to this equation. Again you go back to this equation. This equation is in the form a square minus b square form. Again you can write it using the basic formula as m plus a into m minus a. So make m plus a is equal to 0 and m minus a is equal to 0. So from this you will get m is equal to minus a, and from this you will get m is equal to plus a. Therefore m is equal to a minus a plus or minus ai. These are the four roots you required. So two roots are real and distinct, two roots are complex roots. Therefore using case number 2 and case number 3, you can write the general solution as y is equal to c1 into e to the power minus ax plus c2 into e to the power ax plus, these two roots are complex roots, so I will write this one as c3 into cos ax plus c4 into this is sin ax. Now here alpha is 0 means it becomes e to the power 0x into e to the power 0x. Since e to the power 0x is here, since e to the power 0x is 1, so we are not going to write that. This is the final solution for this differential equation. Okay, now let us take one more important equation as per the V2 question paper. This is one of the most important example. So that is, solve the differential equation 4 times d raised to 4 minus 8 d cube minus 7d square plus 11d plus 6 of y is equal to 0. This example has been asked many more times in the examination. Now very recently, this is December 2019, January 2020, in this question paper it has been asked. Okay, now therefore if it is given in this format means directly we can take the auxiliary equation. Auxiliary equation can be written as L of m is equal to 0. L of m is equal to 0. Therefore this is your LD here. This is your LD. Therefore this becomes, wherever d is there, you need to substitute m. So this becomes 4m square minus 8m cube minus 7m square plus 11m plus 6 is equal to 0. Now this is a fourth order differential equation. Here factorization is not possible directly. Either we go for inspection method or we go for synthetic division method. So let us consider synthetic division method first. Okay, first we will write down the coefficients of these numbers, that is highest coefficient of highest degrees, that is m minus 8 minus 7, that is 11 6. So first we will write down 0 here. We will try with minus 1 first, that is minus 1, 4 as it is, minus 1 into 4 is minus 4, minus 8 plus minus 4 is minus 12, minus into minus is plus 12, so this becomes 5 plus 5. Okay, 5 into minus 1 is minus 5, so 11 minus 5 is plus 6, 6 into minus 1 is minus 6, so plus 6 minus 6 is 0, so we can consider this as m is equal to minus 1 is a root, therefore m plus 1 is a factor. Now directly, so once we extract one root, it will be reduced to the cubic equation, so we can directly try here to extract another root, that is 4 12 5 minus 6. This is minus 6 is a constant number, so we can try it for plus or minus 1 plus or minus 2. As we tried, we will try it for 2, that is 4, 0 you keep as it is, 0 as it is, that is 4 as it is, I'm sorry, adding 0 to 4, 4 as it is, 2 into 4 is 8, add it to the minus 12, so that becomes minus 12 plus that is plus 4, then 2 into minus 4 is minus 8, plus 5 minus 8 is, this is a minus 3, 3 into minus 3 into plus 2 is, this is minus 6, so plus 6 minus 6 becomes a 0. Therefore, what is your conclusion here? Therefore, from the first string, m is equal to minus 1 is the root, m is equal to 2 are the roots, and we can write here, and therefore m is m plus 1 and m minus 2, m minus 2 are the factors. Two factors you have extracted, two factors. Once you have extracted two factors, the given equation will be reduced to the, then one more factor will be second quadratic equation, that is m plus 2, this is m minus 2, then this is using these coefficients we will write down the quadratic equation, that is 4m square, 4m square minus 4m minus 3, this minus 3, which is equal to 0. Therefore, m plus 1 is equal to 0 and m minus 2 is equal to 0. These are the two factors. 4m square minus 4m minus 3 is equal to 0 is a quadratic equation. Okay. Now from this, m is equal to 1 is minus 1 is one of the root, m is equal to 2 is one of the root. Now let us consider this second degree equation, that is a quadratic equation, 4m square minus 4m minus 3. Therefore, now this here, this coefficient, if it is 1, then we can go for Sridhar's rule, or factorization is directly possible. Now to get the numbers, first we need to multiply. To get the two numbers or factorize this, first we have to multiply these two. If you multiply these two, it will become minus 12. Okay, so if you multiply, you must get minus 12. If you add, you must get minus 4. Such two numbers you have to find. Such two numbers are minus 6 plus 2. So that minus 6 plus 2 is minus 4, and 6 2s are 12. That is minus 2. So you can write this one as 4m square minus 6m plus 2m minus 3 is equal to 0. So from the first two terms, you can take a 2m common, and you can write it down as a 2m minus 3. Okay, 2m minus 3 plus from these two terms you can take 1 common, so this becomes 2m minus 3, which is equal to 0. Therefore 2m minus 3, it should be taken common, then this is 2m, you left with a 2m plus 1 equal to 0. 2m plus 1 equal to 0. We got another two roots there. Therefore already we know that m is equal to minus 1, m is equal to minus 1, and m is equal to 2 are the roots. Now 2m minus 3 is equal to 0, 2m plus 1 is equal to 0. 2m minus 3 is equal to 0 leads to m is equal to 3 by 2, and 2m plus 1 leads to m is equal to minus 1 by 2. These are the roots. Therefore, we got all the four, since it is a fourth order differential equation, you got all the four roots. M is equal to minus 1, 2, 3 by 2, minus 1 by 2 are the roots, and you observe here all the roots are real and all the roots are distinct. Therefore, using case number 1, we can write the general solution as, the general solution can be given as y is equal to c1 into e to the power minus x, c2 into e to the power 2x, plus c3 into e to the power 3 by 2x, plus c4 into e to the power minus 1 by 2x. It is not necessary that you have to write in this order only. You can interchange these and you can write that answer, that solution is also valid. Okay. Now you got to know how to solve the first order, second order and third order, fourth order differential equations, homogeneous. Now these can be extended to fifth order, sixth order, seventh order, nth order differential equation also. Now for you can try, depending on these solved examples, you can try these examples which is given here. You can try these examples your home. Okay, with this the solution of homogeneous differential equation is concluded.